Welcome, everyone, to the AI Factory podcast. In today's explainer, we are going to unpack something huge, the evolution of cloud applications. We're going to trace the journey from a really frustrating problem that every developer knows, all the way to the amazing technologies like Docker, Kubernetes, and Serverless that, basically run the entire modern web. Okay, so here's how we're going to break this down. First, we'll look at the developer's dilemma, the root of the problem. Then we'll climb what we're calling the abstraction ladder to see the solutions. After that, we'll get into the portability paradox, some unintended consequences. And finally, we'll peek into the converging future. All right, first up, the developer's dilemma. To really get what's going on, we have to start at the very beginning, with the problem we absolutely needed to solve. This is the why behind all of it. The classic line, it works on my machine. I bet if you're a developer, you've said this, and if you work with developers, you've definitely heard it. It's that infuriating moment where everything is perfect on a developer's laptop, but the second it goes live, it just breaks. And why? Well, it could be anything really. Tiny differences in the system configuration, a different library version, you name it. This one single problem, this created a huge, huge need for consistency across the board. So, how did the industry tackle this? Well, it led to a whole series of solutions, each building on the last. You can almost picture it like climbing a ladder of abstraction, each rung getting you a little further away from the messy details. And that brings us to the first big step up, containerization. The name you'll hear everywhere is, of course, Docker. Docker basically took this idea and made it standard. What it does is solve that works on my machine headache by, packaging the application with everything it needs to run. The code, the runtime, all the libraries, the system settings, it all gets bundled up into a single neat little package. The analogy everyone uses, because it's just so perfect, is the shipping container, right? Think about it. A standard metal shipping container can be picked up and moved by any truck, any train, any ship in the world. It doesn't matter what's inside. A Docker container is exactly that, but for code. It runs the same predictable way on any server, on any cloud, as long as it supports the standard. It completely separates the app from the machine it's running on. Okay, so containers are great. Problem solved, right? Well, not quite. The thing is, modern apps aren't just one simple program anymore. They're made up of hundreds, maybe even thousands of these little containers, all talking to each other. Trying to manage all that by hand? No way. It's just impossible. And that is exactly the problem Kubernetes was built to solve. So you can think of Kubernetes as the operating system for the entire cloud. It's become the standard, Every major cloud provider, AWS, Azure, Google Cloud, all of them supports it. And its job is to automate everything for that huge fleet of containers. Deploying them, scaling them up or down when traffic changes, making sure they're healthy. It creates this one consistent way to manage everything no matter where it's running. All right, so we've climbed pretty high. But what's at the very top of our abstraction ladder? Well, that's serverless. This is kind of the ultimate goal of abstraction. With serverless, developers don't even have to think about servers or containers or clusters anymore. All of that just disappears. You just write these small, focused pieces of code, they're called functions, and the cloud provider, they handle everything else. Like completely invisibly. They figure out where to run it, how to scale it, all of it. Okay, so we have all these amazing tools that promise portability. We should be able to move our apps anywhere, right? The problem of being locked into one cloud provider should be a thing of the past. Well, this is where we get to the unintended consequences. And the reality is, a lot more complicated than you might think. It really brings up this central question. With all these solutions, is vendor lock-in really gone? And the answer leads us to what we're calling the portability paradox. It's this fascinating cycle where every time we solve one problem, we accidentally create a new, maybe even more subtle one. Let's just compare these two head-to-head for a second. You can see there are some major trade-offs. With Kubernetes, you get a ton of control over your infrastructure, and you get really consistent performance. That makes it perfect for those big, complex applications. But serverless, that's all about convenience. And you only pay for what you use, which is great for things that only run once in a while. So it really boils down to this fundamental choice. Do you want more control or do you want more convenience? And this chart shows that trade-off really clearly when it comes to performance. Look at Kubernetes. It's pretty steady, offering low latency because the containers are always on and ready to go. But serverless, you see that spike? That's what's known as a cold start. If a function hasn't been used for a while, there's a tiny delay the first time it's called again. And as you can see, that delay can really add up under heavy load. And then there's the cost, which is just as interesting. That pay-per-use model for serverless is amazing if your traffic is all over the place, spiky and unpredictable. You only pay when it's running. But if you have an application that's running constantly with a steady workload, well, this chart shows that over time, the fixed cost of running a Kubernetes cluster can actually end up being cheaper. And this gets us right back to the heart of the paradox. The whole point of all this was to be portable, to not get stuck with one vendor. But it seems like every time we add a new layer of abstraction to solve one kind of lock-in, we just end up creating a new kind of dependency. Let me show you how this cycle plays out. So Kubernetes came around and solved infrastructure lock-in. Awesome! Compute is now a commodity. But that just created a new problem: platform ecosystem lock-in. Now we're tied to Amazon's specific database service or Google's special monitoring tools. Okay, so then serverless comes along to abstract away that platform. But what happens? It creates event and service lock-in. Now your code is deeply tied to a provider's very specific proprietary event systems and permissions. It seems like true portability is always just out of reach. So the big question is, if every solution just creates a new problem, where is all this headed? What's next? And that brings us to our final section, the converging future. Okay, so a few really interesting trends are popping up because of this tension. The first, and maybe the biggest, is convergence. We're seeing projects like Knative that are trying to give you the best of both worlds, that serverless-style ease of use, but running on top of Kubernetes so you still have the control. Then there's AI-driven optimization, which is super cool. This is where AI basically watches your application and automatically handles all the resource management and scaling to make it as efficient as possible. We're also seeing this stuff expand out to the edge, pushing computing power physically closer to users for way faster response times. And finally, of course, there's a huge focus on enhanced security, with things like a service mesh to manage all the complex chatter between those thousands of microservices. And all of this leaves us with one last big, kind of provocative question to think about. Is the future a single, unified model where all these technologies merge and we finally get the best of both worlds? Or is building for the cloud always going to be a choice? A fundamental trade-off between the amount of control we want to have and the level of convenience we're willing to accept. Thanks so much for joining me for this explainer. If you want to go a lot deeper on these ideas and see how they really connect to bigger global strategy, you should definitely check out the book AI Factory: Architecting Global Supremacy. We've put the link for you right in the description.